Okay folks, in this lesson we are going to be taking a look at the settings tab of the render setup window. So let's open up the render setup window and go to the settings tab and see what we have here. We discussed default displacement rollout in the displacement lesson of the material section. We have system rollout, which contains a few sections itself, and we are going to be going through them in a moment. As always, let's set the interface to expert so we can see every single available parameter. In the first section, we can decide how V-Ray render regions or buckets are gonna go through the scene and render the final image. We have dynamic bucket splitting, and when this option is enabled in order to use all the CPU cores for most of the render, V-Ray decreases the bucket size as the render is about to be finished. If you remember, the size of the bucket is being controlled from the bucket image sampler rollout, and right now it's set to 48. Now, if I get back to the settings tab and open up the frame buffer and select a small region to render, let's render the scene also. You can see when the dynamic splitting is turned on, and as we get closer to the completion of the render, the buckets are getting smaller and smaller, and this way all the CPU cores will be utilized all the time. But if I disable dynamic splitting and render the scene, the bucket size will be fixed at all times. Generally speaking, having dynamic splitting enabled is gonna speed up your renders a bit. Next, we have sequence, which controls the order in which the buckets are rendered, and the default triangulation sequence is the most optimized one, but we also have top to bottom. And if I disable region render in the frame buffer, you can see the top to bottom order of the buckets. And if I want to reverse the sequence, I can enable reverse bucket sequence down here. Now if I render the scene, the buckets are coming from the bottom part of the image. Let's disable reverse for now. We also have left to right. Checker, spiral, the default triangulation, and Hilbert curve. For now, let's set it to triangulation. We have division mode. Right now, the render is divided into smaller buckets based on the size of those buckets, which is 48 pixels, right? But if I change the mode to count and in the bucket image sampler rollout, set the bucket count to maybe 2 and render the scene, now we are specifying how many buckets the image is going to be divided to. So right now, if I set the count or size to 1, only one bucket is rendering the entire image, and basically one CPU core will be used. And if I set it to 2, 4 buckets will be used. And if set to 4, 16 buckets will be used. So the square of this value here. Let's set it to 48, and in the system rollout, change the division mode back to size. And now if I decrease the bucket size to, let's say, 16 and render the scene, we are gonna get very small buckets to render the scene. Okay, let's stop the render and set it back to 48 pixels. And get back to the settings tab, and we have previous render, and by default it's set to unchanged, and that means if we start a new render, the previous render will stay in the frame buffer until the new buckets take over the entire image. And we have A bunch of other modes. For example, if I set it to blue and start the render, the previous image in the frame buffer is going to be tinted blue, so you can simply distinguish the previous render from the current one. Let's set it to unchanged for now. Next, we have some parameters to control V-Ray's binary space partitioning tree, or BSP tree. As these parameters are pretty much advanced and you rarely need to touch them, and as I don't think I can explain it better than the chaos group, I'm gonna briefly explain these parameters from V-Ray's guide, and you can find more explanation of these parameters on the official V-Ray guide. First of all, what is V-Ray's binary space partitioning tree, or BSP tree? One of the basic operations that V-Ray must perform is ray casting, determining if a given ray intersects any geometry in the scene, and if so, identifying that geometry. We talked about raycasting in our previous sections. Now, the simplest way to implement this would be to test the ray against every single render primitive in the scene or triangle. Obviously, in scenes with thousands or millions of triangles, this is going to be very slow. To speed this process, V-Ray organizes the scene geometry into a special data structure called a binary space partitioning tree. The BSP tree is a hierarchical data structure built by subdividing the scene in two parts, then looking at each of those two parts and subdividing them in turn, if necessary, and so on. Now, those parts are called nodes of the tree. At the top of the hierarchy is the root node, which represents the bounding box of the whole scene. At the bottom of the hierarchy are the leaf nodes. They contain references to actual triangles from the scene. Now let's take a look at the parameters in this section. Dynamic memory limit is the total RAM limit for the dynamic raycasters, which store dynamic geometry like displacement, V-Ray proxy object, and V-Ray first strands, and so on. Default geometry determines the type of geometry for standard 3ds Max mesh objects. Note that some objects like displacements, mapped objects, V-Ray proxy, and V-Ray fair objects, for example, always generate dynamic geometry regardless of the setting. We have three geometry types. When set to static, all geometry is pre-compiled into an acceleration structure at the beginning of the rendering and remains there until the end of the frame. The static raycasters are not limited in any way and will consume as much memory as necessary. When set to dynamic, geometry is loaded and unloaded on the fly depending on which part of the scene is being rendered. The total memory taken up by the dynamic raycasters can be controlled by the dynamic memory limit parameter up here. And in auto mode, some objects are compiled as static geometry while others as dynamic. V-Ray makes the decision on which type to use based on the face count for an object and the number of its instances in the scene. Max tree depth is the maximum depth of the tree. Larger values will cause V-Ray to take more memory, but the rendering will be faster up to some critical point. And values beyond that critical point, which is different for every single scene, will start to slow things down. Minimum leaf size is the minimum size of a leaf node. We have face level coefficient, which controls the maximum amount of triangles in a leaf node. If this value is lower, rendering will be faster, but the BSP tree will take more memory. We have use Embry, which if enabled, the Intel Embry Raycaster technology will be used, and this can really decrease your render time, and it is on by default. Now let me show you two renders with and without Embry. In the first render, use Embry is disabled and the render time was 1 minute and 46 seconds. And in the second render, use Embry was enabled and the render time was 1 minute and 28 seconds. So you can see how impressively using Embry Raycaster decreases render time. Next, use Embry for motion blur and hair, which determines whether to use Embry in calculating motion blur and hair strands or not. And we have conserve memory. If enabled, Embry will use a more compact method for storing triangles, which might be slightly slower but reduces memory usage. Next, we have the frame stamp section, and if I enable it here and apply it in the V-Ray frame buffer, It gives us this short bar presenting some selective information about the render, like V-Ray version that was used for this render or the render time. You can edit this information, add and remove any bit that you want using the frame stamp section or directly in the frame buffer. You can use insert variable to add different information to the stamp. In this case, let's add something like the date and the time of the render. And if I render the scene again, those information will be included in the frame stamp. And you can delete anything you want from here. Maybe we can delete the date and the time variables that we just added. Simply select and press delete. And in the render setup window, you can define the font or the justification of the text in the frame stamp and stuff like that. Let's disable it for now, both in the frame buffer and in the render settings. Next, we have distributed rendering, which is the process of computing a single image over several different machines. You can enable this capability here, and using the settings window, add and adjust the machines you want to use in the process. You can find a very detailed guide on how to set up distributed rendering in V-Ray on V-Ray's guide. So I'm going to skip that because it's going to be a long process. Next, we have V-Ray log parameters. When you render your scene, V-Ray writes out different information in a log file that is saved here. And you can define where the file is going to be saved. But we can see the essential part of that information in the V-Ray messages window. If I set the log window mode to always and render the scene, we get this V-Ray messages window containing different information and possible errors and warnings in the render. First, you can define when this window will be shown. You can set it to never, always, only on errors and warnings, or on errors. And using levels, you can determine what kind of messages will be showed in the window. One is, if you set it to 1, only error messages will be shown. If set to 2, error and warning messages will appear. If set to 3, errors, warnings, and informative messages will show. And if set to 4, all the messages will show up. Now let's set the log window to only on errors and warnings. And finally, we have a few different parameters and options. We have low thread priority, and when enabled, V-Ray won't utilize all the CPU cores and you can use your machine for other purposes while rendering. And if disabled, V-Ray utilizes all the cores. We have check for missing file, and when enabled, V-Ray will try to find any missing files in the scene and will put up a dialog listing them if there are any. When optimized atmospheric evaluation is enabled, V-Ray calculates the atmospheric effect like fog first, and if it is opaque enough, the surface behind it won't be evaluated as it won't be seen in the final render anyway. We have shade context in camera space, and if enabled, V-Ray emulates work in camera space by converting the various points and vectors passed to and from other plugins. We have object settings, and you can access this window simply by right-clicking on any object in the scene and choosing V-Ray properties in the menu. We have been discussing most of these parameters throughout the course. Let's take a quick look at the remaining ones. And here you can mostly find per object controls of the motion blur, global illumination, shadows, and object visibilities in different rays. First, let's select any object from the list. On the left side, we have use default motion blur samples, and when enabled, the global samples for motion blur will be applied to the selected object, or you can disable it and define a motion blur sample value specifically for this object using the motion blur samples down here. And you can define motion blur duration specifically for this object. Using velocity channel and multiplier, you can manually specify a map channel to be used as a velocity channel and multiply that information. We can control whether the object generates and receives GIs or not, and by how much. We have GI surface ID, which prevents the blending of light cache samples across different surfaces. especially if two objects have different GI surface IDs, the light cache samples of the two objects will not be blended. We have ray traced SSS ID, and simply the objects with the same SSS ID are going to be using the same illumination sample when using V-Ray fast SSS2 material and when the multiple scattering mode in that material is set to ray traced. Subdivs multiplier is a multiplier for the subdivisions of all secondary ray tracing down for the selected object. We discussed caustics option in the previous lesson. We have some visibility options to control whether the object is visible or not for the GI reflection and refraction rays. Generate render elements. If disabled, this particular object won't be included in some of the render elements. And we have ignore in RT engine, and if enabled, the objects won't be included in the render when using V-Ray RT as the render engine. We have geometry, which allows the user to override the default geometry parameters in the system rollout on a per object level. We discussed matte properties in the V-Ray wrapper material lesson, I guess. We have trace sets. Reflection exclude list, which is an include exclude list that allows the user to specify which objects are going to be visible in the reflection of the current object. So imagine if you have a reflection or a reflective sphere and you don't want to see the reflection of a green box in it, you can set the mode to the exclude and add that box to the list, and this way that box won't be visible on the reflective sphere. Refraction exclude list is an include exclude list that allows the user to specify which objects are going to be visible in the refractions of the current object. So imagine if you have a book behind a refractive glass and you don't want to see the book behind the glass, you can add the book to the exclude list of the glass object. Let's close this window. We have light properties, and here you can control some global parameters on a per light basis. We talked about the caustics option in the previous lesson. We also have generate diffuse, diffuse subdiv, and multiplier. Generate diffuse, when enabled, V-Ray will generate diffuse illumination photon for the selected light sources. Diffuse subdivs controls the number of diffuse photons traced for the selected light, and diffuse multiplier is a multiplier for the diffuse photons. Now let me close this window, and we have a camera settings window which allows you to adjust the motion blur samples on a per camera basis if you want and have more than one camera in the scene. Next we have V-Ray presets window. Using this presets window you can save all the parameters and render settings that you have adjusted to a file and reload it whenever you want, and this can be very useful. Imagine you can have a test preset in which the settings are very low and you can render your scene very fast, and use this preset at the beginning stages of the project and have a final render preset with higher quality settings for your final render, and you can switch between those two sets of render settings by just one simple click. So let's see how we can save the current render settings that we have as a render preset. First off, let's name the preset and maybe something like test. Now on the right side, select which rollouts you want to be included in the preset. And let's select all of them and press save. Now as you can see, we have a test preset in the preset list, and it can be loaded anytime. Simply select the preset, choose the rollouts that you wanna be loaded from this preset, and then press load. And this way all the settings in these selected rollouts will be according to the information in the preset file. Let's close this window for now. In the texture options rollout, we have cache size, which specifies the size in megabytes of a separate texture cache to be used for tiled OpenEXR files. Note that the cache size cannot be decreased from its initial render value, and if you set it to a lower value, the value will not be used by Max until you restart the application. And we have clear cache on render end, which causes V-Ray to clear the texture cache after a frame is complete in order to avoid slowdowns. Okay, so that's about the settings tab, and I will see you in the next lesson.